Okay, so the objective. So here's the objective for today. Let me grab my pen and pencil. So the objective, today's objective has to do with finding volume of a prism in metrics. Okay, metrics. Metrics are like centimeters, millimeters, decimeters, hectometers, decameters. No, not inches. Inches are the English system. So inches are silly and sort of feet because you think about it, inches you get, oh, wait a minute, first of all, if you take an inch, you got a half an inch, then you got a quarter of an inch, maybe an eighth of an inch, then you got 3/16 of an inch. That's just for me confusing. Centimeters, I like centimeters because 3.2 centimeters. In fact, when I build things, I'm not much of a builder, am I? But when I do build things, I like metric. I don't like, what is that? Is that 4 and 3/16? Is that 6 and 7/8? Boy, there it is. It's 20.8 centimeters. Bam, it's easy, right? We are the only country in the world that uses inches. Are there 3?
Yeah.
Who are the other 2?
I don't know, but they aren't like big countries.
Yeah, it's silly, isn't it? Yeah.
Yeah.
So when we do this, we're gonna make a little discovery of something here pretty soon. But first of all, let's go right off the bat. A prism. Define a prism. So I mean, I don't know, prism. What do you think? What's a prism? Give me some ideas. Yeah, Cody.
A shape with no gaps or curves.
Okay, that's good. Okay, that's a good start because that would be part of it. That's a good. That's not all of it. It's part of it. Yes.
Like a linear, three-dimensional object.
Three-dimensional. Good. So what did you say, Cody?
Shape.
Shape that is closed.
Yeah.
You said three-dimensional. Landon?
I was
No, go ahead.
no, I was going to say what Cooper said.
Okay, good. Okay.
A three-dimensional object that has multiple faces.
It can have multiple faces. Yes. So but what are the faces? Could be, yes, sides, right? Ben, you had something?
I just said a 3D shape.
So it's 3D shape. So is a sphere a 3D shape? No, it's a ball. It's sphere's a ball. That's not a prism. No, it's a 3D shape. Is a pyramid? Is a pyramid a prism?
Yes.
Yes.
No, it's pyramid.
Oh.
It's a pyramid.
But aren't pyramids called like
It's a pyramid.
rectangular prisms?
Oh, a rectangular prism. That's a rectangular prism.
That's a box.
No, it's a rectangular prism. It's not a box.
It is.
It's not a box. It's a rectangular prism.
Well, it has a hole in it.
Well, okay, there we go. Anyway, so this is a rectangular prism. Cody, let's go back to your first definition. What did you say about something? About being enclosed, right?
Yeah.
So is this thing here enclosed? Sure it is, right? What's this thing here? What's that called? It's a rectangle, right? It's a rectangle, okay. Ellie, what did you say about faces? It's got 1, 2, 3, 4, 5, 6 faces, doesn't it, right? Okay, good. All right, so we're getting closer to definition, but what makes this different than a pyramid? Pyramid? What do you think? Yeah, Zoe? Bijou? Sorry.
Is it because it has like a pyramid?
Pointy.
Yeah.
Pyramid pointy. This isn't. The top is not pointy, is it?
No.
I want to keep going back to what you said. Though. It's coming. Yes, Ellie.
The two faces on the top and bottom are the same.
Yes. You're getting really close to definition. You want? Now, you ready? Okay, these are called bases. They can't be faces. These are bases, not faces, because these are the sides, right? Called the faces, and these are the bases. But then if I do this, and this is a base, and this is a base. Then if I do this, whoa, right?
Wait, and then these are pieces.
Yes. Just depends on how you draw it and how you put it all together. Now some things, though, are going to be obvious bases and faces. So let's give ourselves a definition. What do you guys think? Okay. So let's go back to 2. Has to have 2 enclosed, parallel bases. Okay, Cody, that was your definition, kind of, right?
Sure.
Okay. Now, Elliot's got to have faces, right? So it's got to be 3D. So it has to be three-dimensional, 3D with sides. But we're going to call those faces. How's that? Okay. Now, let's draw one. Okay. So let's see if you can draw this. And I'll slow down for a second. How do you find the volume? How do you find the volume? Cross it out. I can't spell. Put a prism. Okay, change that word to prism. I should have proofed my... So, now we kind of got an idea of what it is. So let's draw a picture. Let's see if you can draw this. Draw a rectangle. Okay, everybody draw a rectangle. Okay. Okay, now, right behind it, draw the same rectangle. Do you see where I'm going with this? Okay, right behind it, draw another rectangle. Right? Connect the dots. Right? And so that's a prism, isn't it? This would be a rectangular prism. Yeah, it's a box. It's not a cube. It's not a cube. It's a rectangular prism, okay? Now, I'm going to draw this, and if you want to just watch, you can. If you can draw it, great. You don't have to. It's kind of hard to draw. I've been doing this a long time, so for me, that's no good. Thanks, you guys. If you can't draw this, don't worry about it. I don't even draw it all that well, okay? I just want you to look at that, okay? All I want you to do is tell me the name. Say X. Say it.
Is it Hexagonal Prism?
Yes. Yes, it is a hexagonal prism. Good. Yeah, it's a hexagonal prism. Does it fit our definition?
Yes.
Yeah, it does, doesn't it? Okay. Okay. You don't have to draw this, but let's just see if you want. If you can, it'd be awesome. If you can't, don't worry about it. Okay, and if you can't draw it, don't worry about it. I just mostly want you to be able to tell me what the name is. The name should be obvious, right?
Triangular.
It's a triangular prism. Everybody agree?
So is it,
Yeah, Ben?
so it's classified by how many like sides the bases have?
Yes, it's classified by its base, right?
So if you flip the hexagonal prism over,
Yep.
it'd be a rectangular prism?
No, that's the great thing. This one we can flip over, right? It doesn't change its name. This one, the hexagons have to be the bases. They have to be.
Like the biggest one.
It's not even the biggest. It has to do with the faces are the... What are the faces? What are the sides? What's the figure? What shape are the faces? They're rectangles. So the faces have to be rectangles in a prism. You got it? Ben, does that help? So your faces must be rectangles until we get what we call a blob. And we're going to talk about the blob tomorrow, okay? Blobs tomorrow, okay? So now, how do you find the volume of a prism? Okay, big V for volume. Okay, ready? We need this. This is really important. V for volume. It's simply going to be the area of the base times the height, okay? How am I doing, okay? You guys have learned something today, haven't you? Wow, first day of school, we're already learning things, huh? Okay, so now, what is a liter? Anybody know what a liter? Give me an idea. What do you think, Cody? What's a liter?
It's 1,000 milliliters.
Nice. It's 1,000 milliliters. It is. What's a milliliter? Awesome.
1,000 milliliters.
Okay, that's a good answer. It is.
A unit of measurement.
Yeah, okay, it is your volume. Okay, you ready? Here, Cody, catch. What's a milliliter?
This.
Yes. It's 1 centimeter by 1 centimeter by 1 centimeter. Okay, you guys gonna say that?
I said what?
Here, guys, roll back, okay? So that means 1,000 of these should fit in here. That's a liter. So he's like, how in the world are you gonna get 1,000? Well, you gotta cut them up and squish them up, right? Right? And so, whenever we deal with circles, we gotta use that special number. What's that special number we use? We use pi. So we get a decimal type answer, don't we? Because really, you could never fit 1,000 of these in here, could you?
Yeah.
You'd have to chop them up, squish them up, make them into jelly, and then pour them in, right? And so then that's where you get your 1,000 of them, but you will have 1,000 of these, good answer, in there, okay? So what's a liter? Let's put it down. Liter is, it is 1,000 centimeters cubed, all right? Now what's a centimeter cubed? It's like centimeter by centimeter by centimeter, okay? That's a liter. Now we're going to talk about metrics, right? So let's just go ahead and let's put down some metric stuff. But if I get going too fast, say, Mr. Davies, can you slow down, please? And I will. Everybody give you a minute or two to catch up.
Yeah.
Okay. All right. So. Which one's bigger?
Tallest.
Good, good. What's the difference between these two? Not the fact that they're taller than that. They're different.
One's black, one's white. One's white, one's
There you
white.
go. There you go. Okay, what's the Cody? What's the difference between these two? Don't answer.
Width.
What's the answer? Yes.
One has 7 meters, 1 inches.
Great. Good, good, good. So this one's a, Cody, go ahead. That's a meter stick. What's this? A yardstick. Okay, a yardstick. We got a lot of catching up to do. It's okay. It's all right. So 1 meter, which is awesome because everything's in tens. It's like decimals. It's easy. You don't have like half a yard or 3 feet and 2 inches and half. It's like everything's in tens, right? So you take it, and all of a sudden it goes 10, 20, 30, 40, 50. These, this much right here, we see this much right here, this length is a decimeter. This length right here is 1 decimeter. It's 10 centimeters, right? You got it? This one, see where my fingers are? This is 10 centimeters, which is 1 decimeter. Don't worry, we're going to write all this down, okay? That much length is a decimeter, okay? So there's 10 centimeters in a decimeter, okay, got that. There's 10 decimeters in a meter, okay, got that. So then there's this little tiny little, that much, like the thickness of a dime, is a millimeter, got it? So there's 10 millimeters in a centimeter. There's 10 centimeters a decimeter. There's 10 decimeters in a meter. Got it? Okay. We're gonna do something. Okay. Now let's go big. Okay. So 10 of these. Not yet. Not yet. That's 1,000 of these. But you're heavy. Okay. Close. 10 of these is a decameter. 10 decameters is a hectometer, and 10 decameters is a 10 hectometers is a kilometer, right? Right? So then there's 1,000 of these in a meter, in a kilometer, right? I know.
Wait, is that the K?
That's the K. So let's write that down, okay? So here's how we do our chart, okay? We're going to start at this end, okay, length. We're going to put mm for millimeter, okay? We're going to go right in the middle. We're going to go m for meter, okay? Now we're going to make 2 dashes, a dot there and a dot there. So we're going to kind of divide it up into thirds, right? And there's my centimeters, and there's my decimeters. We're going to write these down. There's my millimeter, my centimeter, my decimeter, my meter, okay? How am I doing? Going too fast?
Yep.
Okay, slow down. Then we got way out here at the very end, kms for kilometers, or kilometer. We say kilometer, right?
Can you just write K? We'll say I ran a 5K.
No, well, you got to go km in here. It's got to be km. So if you run a 5K, you're running 5,000 of these, right? 5K, 5,000 of these.
Yeah, but like
Yeah.
5 kilometers.
Yeah, but you got to go km. Okay, so kg, there's kilograms.
So it's like in
There's
percent.
KLs for kiloliters. So it's just got to be kg. km, sorry, km. So divide this into thirds, right? We have the DAM, which is your decameters, and then HM for hectometers. So we'll put that. Go ahead, Zoe. DAM. I know it sounds like DAM. I know. For decameter, hectometer, and then kilometer. Okay. Okay. How am I doing so far? Everybody have that? Yeah, it's hot. Sorry, you guys. Yeah, they said it was going to be 100 today. It's like, oh, bad time.
Why does
Okay.
it all start?
Now, you ready? Turn your paper over. Turn your paper over real quick. Okay. Put your paper over. Okay. So, we're going to convert 34 centimeters to meters. Well, before we do it, let's just make sense of it, okay? So 34 centimeters, let's just see it. Let's make some sense, because math, believe it or not, math can make sense. Okay, you guys agree 1 meter?
Yes.
34 centimeters, so it's not even going to make a full one, right? So the answer can't be 1, it's got to be less than 1, because that's a meter, and this is how much we're talking about, right? So the answer is going to be a decimal answer. Do you agree with that? Yeah, it is 0.34. Now let me show you how to use the chart. So if you have a difficult time seeing it, find the decimal. Boom, everybody read? The decimal's right there. Okay. If you want to see an easy way to do it, flip your chart. And you want to go from centimeters to meter, right? So you're going to move the decimal. Watch, are we watching? You're going to move the decimal 1, 2 places that way.
Does that actually make sense?
Yes, it does. Ready? We're going to go from centimeters to meters, right? So we go from centimeters to meters, we move the decimal. Ready? 1, 2, that direction. Yes, Bijou. So that means the answer is 12.34. And that's now going to be meters. And if you want to put the 0 in front, you can. Some people like the 0 in front. Technically, you're supposed to put the 0 in front, but if you don't, I don't care, okay? Now, how about 4.5 decimeters to centimeters, okay? So, yeah, you go straight to the chart, which is great. So before we do it, it's really easy. 4.5 decimeters is there. See where my finger is? You know it's 45, right? You agree? 45 centimeters, right? But if you want to use your chart, you find the decimal, right? And it says, okay, decimeters to centimeters. You move the decimal. Ready? Watch your finger. Just go 1 that way, right? So the decimal's going to go 1 that way. So just 1 that way, and it's 45 centimeters, okay? Now, 345 centimeters squared. Okay, now this one's going to be a little bit different because I just want to give you a real quick picture, okay? We'll draw a picture right here, real quick. Just draw a picture. 10 centimeters, okay?
Can only see like
Thanks, you guys. Yeah, no, I get off because I'm looking here and out there, but thank you. So, just watch, okay? How many square centimeters are in that box? How many square centimeters in that box? 100, right? How'd you guys come up with 100? That's right. Mr. Daly. You just multiply. But what if I drew a picture? You're going to have to add, right? But you got the idea, right? You got the idea? So if you had to count them up, how many did you get? 100, right? But now let's choose our chart. We're going to go from, you guys said 100, didn't you?
Yes.
Did you say 100? Yes. Okay, let's go to our chart, okay? Centimeters to meters. 1, 2, right? So we're going to move the decimal. We're going to move the decimal 2 places.
Yes.
No, we're going to move it 4 decimals because we're in 2-dimensional space. Because when we move in area, you are moving length and width, length and width. You're moving length and width, length and width. So you got to move it for the length and the width. So you got to move. So let's fix our chart. So let's take a look. Flip the page back. So put your millimeters squared, centimeters squared, decimeters squared, meters squared, decameters squared, hectometers squared, kilometers squared. Okay? Now, we're going to add some little dashes, okay? Because we're in 2D space. So when we go to 2D space, we are moving length and width. Length and width. We move both length and width, so we're moving twice. That makes a little bit of sense, right? So now we're going to put 1 in between each of these. 1 decimal point in between all of these, okay? How am I doing, okay? So now, if we want to go from millimeters squared to centimeters squared, we move the decimal 1, 2. If we want to go from centimeters to meters, we're going to move the decimal 1, 2, 3, 4. Length, width, length, width. That's why we move it twice. So, if we're going to go from centimeters squared to meters squared, centimeters squared to meters squared, right? See it? Centimeters squared to meters squared. We're going to go 1, 2, 3, 4 that way. So we take our decimal, find our decimal, we move it 1, 2, 3, 4. So we're going to have a 0.0345 centimeters. Whoops, I'm wrong. Meters squared. Okay. It's not even a square meter, is it? Not even. Okay, now 10 decimeters cubed. Okay, so let's draw a picture. Let's draw a picture. Okay, there's my cube. You guys got that? Okay, there's my cube. And it's going to be 10 centimeters by 10 centimeters by 10 centimeters. Okay? Okay, easy question. Easy question. It's already been answered. How many of these are in that box? 1,000, right? It's going to be 1,000, right? And one way you can do it visually is you can just go, 10, 1, 2, 3, 4, all the way 10, 10, right? You with me? 10, and you can see all 1,000 of them up there, right? See how I can just break it up? So now, we're going to make that. We're actually going to stop for a second. We're going to make that box, okay? So, and I'm going to help you make it. Grab some paper, pass it back. Grab some paper, pass it back. Grab some paper, pass it back. I need a ruler.
Wait, 1 per person?
1 per person. Yeah, 1 per person. Everybody's going to make one, okay? And if you need rulers.
Thanks, man.
If we get really close to it,
Now, first of all, just to be a little helpful, the length of this is 30. That's very helpful. Well, what's the pattern we're going to make? We're going to make a 10 by 10 box with a ruler. Your pattern is probably going to look like that, right? And then you should put tabs so that you can glue it together or tape together. Tabs, tabs, tabs. So I want you to make this box. And I'm going to stop recording right here. Okay? And I want you to do a really nice job If you have paper you're going to throw